Today's date is so this video I'm showing the draft here. It's basically on the second protocol. Guys, it's just a step. Now, so I'm gonna specifically, I'm still going to consider the 10. I'm still going to consider the second. Let's remember as a cell. I think human rights protocol that can give you free one in a shot. So this is part 2. So part 2 is I take messages. Yeah, I got my inputs here. It should work kind of formally. So for more introduction to it. But it should be or not, or anyone who wants to work with me on it. I don't want to be perfect. So you get kind of a system system of solution. So we get my diagrams here. But here we get here we get model of it. So these images here, something I'm showing you, is basically 3 planets orbiting each other. And the orbiting for a reason, the object is stable, they unstable. Basically, I'm trying to have 3 pointers orbiting each other based on magnetic electric position. So the magnetic properties of the electric system is that these 3 planets are a magnetic field, but it's not an electric system doing that. It's a field. The field is a medium, and the medium is a medium compensation. So basically, the goal is to have the rotation mechanical. So if you have a 2-point system, like I'm just using a black hole white hole model to do this via dark matter. So basically, force equals mass times ratio. Einstein's theory of gravity, energy equals mass times constant squared. So this negative mass. So you have mass, you have negative energy. So negative energy means something is pulling. If you can push something, negative energy means you're pulling something. But normally this have the anti-conjugate model, so you can't have easily this model there. So you can understand that basically this is basically the magnetic spectrum, electromagnetic spectrum of planet or potential. As you can see, there's a planet here, nothing, and a planet there, and a planet here. So 3 planets. So as you can see, that's the 3 planets there. But they have a magnetic polarization. So basically, they have the digital electric signals measured as magnetic properties. So I'm just writing code on this way around. I'm trying to take electrical signals in the world in the computer system and measure them as and reduce them into a code. Basically, I'm trying to create a direct alternating current, a stable alternating current in a magnetic system. But this always sends a message. So once you send this kind of message, it cannot be retrieved. You cannot give it back. It's just gone. It's not destroyed. It's just going through a medium, and the medium cannot give it back. We can always check it. So you can understand it's a magnetic system. That's the first one. So it's a magnetic memory model. No, a memory model. So you're gonna have that there. You're gonna have North Pole, South Pole, North Pole, and you're gonna have 4 types. You're gonna have a 4 main orientation. You're gonna have one facing north facing north, north facing north, and south facing. So you have to have 2 magnets to do this. 2 magnets, 2 pendulums are very crucial for stuff. So let me try to get it here. So the benefit of this is you're gonna have in total, in total, 3 sets of magnets. Yeah, is there 3 planets or 3 cosmology, 3 cosmic celestial bodies. Like 3 planets orbiting one another, pulling one another. So as you can see in this image, these 3 planets are orbiting one another, but they are literally magnetic. So they have a magnetic field around them, and you're gonna formalize on the field to create a stable orbit. So this is basically when you jump into this void. What is the void? Because it's a future flash sequence. So future means future explode or nuke sequence, but it's not a nuke per se. It's just send a message. It's destroying the message in time. But it's not destroying the message. It's not doing anything. It's just like it's a filter. So filter means sorting messages out. Flashing means sending messages. Flashing means like the flashing, so flash means stop or send. So basically, the filtering is the filtering. So basically, the message is stored in the magnetic poles. They're not polarized. Basically, basically the messages are polarized. So the flash is basically first. You get stored. These are stored magnetically. The magnetic electric field. Because I'm saying magnetic first, but it's different elements. But the electric messages are stored as magnetic sequences. Basically they worked on the kind of orientation, and so you get rotation, you get group picture, you get displacement. So basically they have a poles, and the poles are isotropic. That means isomorphic and topological. They work on the kind of a topology, kind of a pi, a 2 pi r and pi r squared. A kind of framework of system. But I'm just going to very formally now to guys start the video. So here I said Microsoft Chorus. So you get south. This equals south gives you repel. So you have the repel property in south. This repel property will be in a state of superposition. For example, you're talking about the protocol. So I'm gonna try to do it properly here. So let me sit down here. So we're gonna have this message here. I lost the step. You're gonna have 1 second, let me put my face back up. Yeah, gonna put myself here. You're gonna have 4 dimension, which is magnetic. So you're gonna have rotation of the system. You're gonna have this here, this model here. You're gonna have pi 4. This is the rotation, but this is a polar vision point. Basically, it's polarized pi 4. You're gonna have pi 4. You're gonna have 3 magnets. Pi 4, 3 magnets. Pi 4, pi 4 of rho. It's kind of a gimbal of rho. Rotation. So you can orientate pi 4. So this is rotation of pi 4. Rotation pi 4, pi 3, pi 2. And pi. But that's sequence instruction. So you're gonna have translation multiple times. You're gonna have the angle. So rotation or displacement. So displacement will be so you're gonna have displacement here. Well, displacement will be magnetic properties. So now we're gonna have displacement magnetic. So we're gonna have to move something in the field, you have to change the rotation, and that's going to displace something. So displacement will be the kind of movement of the magnetic pole, the magnet itself, because you have two magnets that you go to is a range that you can have. But if you induce a current, if you just an electron, if you just induce an electric current in a wire, and the wire is in a coil, you have something that's magnetic and it's dangerous. But you have electromagnetic. Now you just get magnetic to electric. So the magnetic qualifier would be electric if it's basically bound on. So you get magnetic pole, which is basically transpolar is north. So pi 4 is north. Pi 3 is south and east. Pi 2 is 1, and pi is west. So that's pi. You're gonna have that model there. You're gonna have pi 4, pi 3. You're gonna have the position. You're gonna have the displacement. Now, displacement is basically movement. You're gonna have units of let's say you have 10 meters, 10 meters, 10 meters, 10 meters, 10 meters, which would be 10 meters, which would be 10 meters units, which would be 100 feet, 100 feet, 10 feet, 100 feet. So 10 meters, 100 feet, and then you're gonna have which 100 steps, 100 steps. So you're gonna have 10 meters. The 10 meters represent velocity. Basically, you're gonna have 1 to 10 meters, 0 to 10 meters. Based on the pole. But the poles are oriented to the around blocks of close to displacement, rotation, and standing. So you're gonna have that. So the message, the magnetic pulse, basically the pulse of the field. The pulse of the field, basically, I'm putting a pulse because this is a pulse. You go that structure direct based on the chemical elasticity also. It's gonna be like a spring. Basically, the more basically don't put more force to it. Because some use spring model because the spring model is basically what you use it. So one using the model, but spring for essentially, if you're sick, basically it's gonna be elastic, elastic model of the system. So it's gonna be very important to understand this because the 10 meters, like if someone goes to 5 meters, 5 meters, and the man goes to 10 meters, after put half the force, and half of the force is half was K times E. K is the stiffness, and E is the elasticity. I think K is stiffness. K equals the stiffness of the spring. You know. So force. Force equals K. So half of the force, half of the K, half of the stiffness, would be equal to potential the work done. So the work equals force times displacement. Yeah. So the force would be and the potential work, potential energy of the system would be the system that's stored in something. It's a stainless energy model. Message model, the stainless message. So the message will be sent if it gets to the point of implosion. And you can't constantly message from imploding because you need orbits of joint code to collapse the message. So basically, potential energy equals the work equals to half of this K, which is stiffness times E, which E is the coefficient. Now this is the coefficient is some graphic. So basically, I don't know what E is, but basically K is a quick slope. Basically key monotonically. So if the stiffness is half, then E so that'll be E would be E equals force divided by K. And half of E would be half of E divided by half of E would be 1 divided by 2. So half would be 1 half of E more than more than or equal to. That's the times, but it's like that's KFC. So keep the sign. So flip the sign. So basically, keep the sign. Keep the sign. Flip the sign. Keep the numbers. Obviously, keep half. Flip the sign. You're gonna minus 4 times K. Half of it. Change the number. So the change will be 2. So half of the energy will be 2 times the force. Basically, it goes in an area of a half. So if it's a quarter, it would be like 2 half. You have 1 half E. I can't remember what E was, but it's a K's coefficient. Then equals this is the half K will be less than or equal to 2 force of 2 times force of K. The stiffest, this is like putting the spring, put something that basically counts one issue on the side. Because the messages are basically it's like the density monitoring increases based on exponential laws of a system. But it's usually cost factor. So because it was 2E, so the coefficient was 2E, but the coefficient for E was a half. So the power basically the power basically the coefficient was a half of E less than equal to 2 of the force times K. So I'm writing this video back then, but basically the doesn't matter how much you put in, how much the method program. It has to be set, which is obviously set. Basically, it's a magnetic minimum model. But since you emulate safety, it's kind of have a course, really, safety, so so this is what I wrote it down here. Hope you guys like the video, but basically I haven't things monetarily increased. That is the area on the curve. Because so once you put the set, you have more space to set, and this can be the memory allocated ahead of time, based on observation coefficient of the bytes model. Let me go on. 1 second, let me go into the toilet. So that first step to the system. You watch my vision. Expect this. So so multiple just means that it's usually gonna affect the system and bring total then it's a factor of the monetarily growth, which is basically kind of think of I one over epsilon, one over Euler's number. So you're gonna have the second one here. What's this video called? 16 minutes. You're gonna have that. So I go here, and I use polarized. You're gonna have the orientation of the magnet 5 degrees, 9 degrees. But you're gonna have a vector. So you're gonna have force, which is auxiliary force. So the force is not there. So if you think of two right-angled vectors, if you imagine this, you're gonna have so you're gonna have the vector is 10 5 6 6 5. So again. Yeah, so you're gonna get 6 plus 6 plus 5 is 10. No, 6 plus 6 plus 5 is 11. 6 plus 5 is 11. 11, 11. And 5 is 11. So you're gonna have 11, 11 here. But you're gonna have the dot product. So you're gonna have the dot product. So you're gonna have 6 times 5. 6 times 5 divided by 2. How am I saying? So I'm trying to work this out. So basically you're gonna have, if you have a vector 6, 5, and you have the vector 5, 6. 6 times 5 is 30. 5 times 6 is 30. So the shear units of 30. That's dot products, but the cross products will be the orthogonal projection. So I'm looking for the cross product. So the cross will be polar. So basically, this would be this is so I'm saying. So I'm trying to find the cross product here. It's my computer. So you're gonna have the cross product of cross product of vector A 6, 5 and B 5, 6. You get numbers. Calculator. Basically the orthogonal vector there, 5, 6, 5, 6, 6, 6, 5. So you're gonna have minus 11. Why is the answer here? Vector code. You're gonna have minus 1. So you're gonna have solution again minus 11. So minus 7 is a scalar. Minus 11 is a scalar, but it's just a number. So this represents because they are the same number, they're the same vector length. You can't have three numbers, so they're basically the same. The zeros, so you're gonna have minus 11. And the quantity to change, they change by 7. This is the z-axis, this is by 7. So you're gonna have the steps here, 6 times but you're gonna have u1 times v1 equals v2 times v3. v3 times, so you gotta transpose all the vector, then multiply it. So you're gonna have 6 times 5. So again, myself, this represents kind of a medium of power of the trans. You're gonna use this again. So you're gonna use you have to take the transpose of the matrix of one of them and put it into another matrix. So 6, 5 to transpose of 5 to the power of 6 is 5, 5. So 5 times 5 is what? 5 times 5 is 10. The 5 times 5 is 25, and 25 times 6 is what? No, 5. So you're gonna get minus. So you're gonna do minus operation. So try again. So you're gonna have 5 times 6, 30. 6, 5, 6 plus 5 times 5, 6 times 5, 6 times 5, 30. Minus 6 times 5, 30. Minus 5 times 6, minus 5 times 6. Minus 6. So get minus 6. Minus 6. Then you get plus the 5 times. So it gives you 6 times 5. 6 times 5. Because you rotate it, go and flip it, go. Minus 6 times 5. 30. Minus 5 times 6. Or 6 times 6. Minus 6 times 6. 6 or 6 times 6, 24 minus 6 times minus 12. You get my 11. But you done it wrong. So give my 2 cents. I get on the stuff, yeah, but so it's a scalar. So you cannot have it's always like a situation equal. So you're gonna have models, you're gonna have that one, you're gonna have that removed from the system, but you're gonna have something minus soft powers, you're gonna have the cross product, so you're gonna have the dot product. And those products usually 30 we're gonna choose complete. We're trying to compute the kind of right hand rule of the system. The left left my left hand to my right hand. Like a stupid person. But I'm saying to you, that's what I'm saying. So you're gonna have the right hand rule to control it. Yeah. But basically geometry space. So you're gonna have that there. So let me go to video. Yeah. Video here. So you're gonna have that there. So you're gonna have so basically my guess is so basically the going to have a message, in 2 minutes already. This is really be there. So how would this work my message? So something else. Say you have so basically because the system can already have the encoding on the NSIGII encoding. So basically you get NSIGII encoding on the system. The linkable data system encoding, which is the linkable data encoding. You can have the encoding there. So you can control the codec, the decoder of the system. But the message is really there. Any artifact should be able to index the encoding itself. So this is you can say the way right to it. So anything you can do is you're gonna have 2 separate encoding on one computer, and you really know when you open it. So if you run the open command of an artifact with a zip, you're gonna have the coding there. So let's set up this radio model of it. A radio model. So this radio model of it. So basically have a sender, a recipient, and a ledger. So a ledger, but you're a both ledgers system. So you are a sender and a ledger. You're a sender and a verifier at the same time. So you have a recipient and a verifier at the same time. But the ledger, anyone who wants to keep blockchain track of the system is a ledger. So it really works because it's I'm trying to go into blockchain, but it's basically because it's magnetic memory. So basically, you're work on kind of cosmology plans, polar orbits, or types of kinds of planet orbits, or types of planet orbits, if you will, via heterogeneous model. So that has to go there. So it may sound counterintuitive, but I believe it works. So the message basically spirals into a state of collapse, and the collapse basically the message says it's like it has a black hole in the center, and the black hole in the center of the planets is where it is. So all the messages, all the packets, orbits in space, in time, orbits in space when they're going to the latitudinal model. But they work on the GPS signal. So you're gonna have do half some kind of you're gonna have very important understand this, guys. Next step, you're gonna have half. So you're gonna have half. So because in the GPS system, you're gonna have a GPS model. You're gonna have half rotation, 2 times the power. 2 times the set. Basically, 2 times the pull. So basically, if you have half push. So if I pull a string and it's a half, I already have 2 times on the other side. So if I have something that's already done already. So if I have to pull, so if I do half a rotation, I have to have double the rotation on the other side. So the message of the configuration, it triggers the configuration on the coding. If I'm saying something's a half on one encoded side, that means that he has really half. When the message is received, you get a file format that's basically the zip file, and that's if I already knows that this conversion is double. If you have a quarter of the rotation, which is 4 divided by 4 of the rotation of a system, like rotation being a polar rotation, or rotation of basically you gotta have graph. You gotta have rotation means a geometric rotation in sparse space, in the space local space or latitude model. You're gonna have half rotation. So that's the question. If you have half rotation, your quarter of rotation, you're gonna have 4 times the message part. So you get 4. A little bit of 4 over 4 will be full message. 2 over 4 is half the message and half a system. So you get you can have it as a 3 pack. You're gonna have, so if I have one third of the message here, I'm talking about having 3 times 2, so if I have 1 divided by 4, I have 1 unit of the full verification, but there's space for the other 4. So if I have half, I have 2. If I have 1 4, I have 1 4. Basically, 1 4 is 2, or 1 divided by 4. Okay, 1 divided by 2 equals to 2. That would be less than equal to 2. Less than equal to 2. And 1 divided by 4 times 4 will be, the force will be 4E. 1 over the force of K, 1 over the force of E, 4E, so 1 over the force of E, where E is the growth factor. The growth factor basically equals to 1 equals to force, negative force. What did I write down? Basically, all books and Hooke's law. Let me try to find Hooke's law here. So basically, it has to grow exponentially via a quadratic curve, but the signal has to be channel verification. You're gonna have a ledger, so that I don't want to basically I want you guys to win, but that's not the ledger, but I don't have the ledger yet. So anyone that's on most, you can have the ledger be verified with the ledger too, because you're consuming the artifacts. So listen, the human rights of the Muko as X mic Q for block Q for Q for Moscow. So you're gonna have something that's once you get 1/3, you get 1 divided by 3 of E, or 1 divided by 3 of 1 divided by 3 of K. Now K is the stiffness. 1/3 of the stiffness equals 3/4 1 times 3. So basically you have to do times 3 on the other side will be 3/4 of the force you've created in one system, and that would be the modular value of the spring over E, where E is basically Hooke's law. I don't know what Hooke's law, I can't remember, but it's just a question of minus E, because you get it will be less than, less than or equal to two systems. Basically, solve a symmetric equation based on the kind of inequality of a system. Keep flip change is the goal there. So that's how that works. I believe it does work. Well, obviously MPP, but basically the CP file is a codec system, and the codec system is it's just what you need to update, what you need to roll back. You don't need to you just need to roll back to update. If you cannot get a message, that means you have an update to codec, and the codec stands for what's in the artifacts. So if you get a zip file, very important stuff. So the room of rotation you have. You have a zip file. Now, a zip file can be any output you have, but that will have to be codec. So the codec, so you do two main ways to do it. You have a zip file. You get the file format A, B, C, Alice, Bob, and to Alice. So okay, message to Alice. You can have from Alice to Bob. Bob dot Charlie. I need help now. Let me keep properly. Bob to Alice. Bob to Alice, I need help now. Bob. So basically, the message Bob will say, Bob to Alice, I need Bob to Alice, I need food, water, and shelter now. And Alice then says, okay, this message basically signature. Signature, I need food. Bob sends this message. The Bob's message is in a text file. I need food now. Now, there's no time stamp here because I don't have time stamp, because it's gonna have new module. So when Bob sends this, when Bob has half of the half of the force, he equals to double the potential force, potential energy of the same force on Alice's system. So they have to share the same codec. Codec, that's basically the linkable technical alphabet, and to November, Sarah, FA, for gold. So if both of them actually send this message ever and again, they have to have codec. So they have to sync the codec services. Bob sends the codec, sends the same message. Bob sends the message, and this message will the codec, and the codec will be bob at gmail.com. So you send the NSIGII file. Bob.NSIGII. So Bob sends the file. But now Bob can send a message as over SMTP. So you can send this codec over. This has to send it over email. You can send it to NSIGII sends artifact via simple mail transfer protocol (SMTP). So this SMTP protocol, and it just sends he just sends artifact. This will just send it to Bob, and you continue to update codec. So the codex updates. Say you have to write a Python script, Python file, guys, and the Python file is the code. So the Python file sends NSIGII.bob.NSIGII, and that's not the message. And then Bob in that artifact, in that zip file, basically, Bob says zip file, saying a zip file containing a text. I need help now. I need help now. Help now. Help now. So continue to the sentence. No time. Let me put time spot. So the time now is 30. So let's say the message is arriving, because it doesn't make sense if I'm not doing this properly. So I'm doing this is what I'm saying. It's doing properly, but I'm not thinking about properly. So I'm saying, so the date is now 30th of this is now. So the date is 2nd of January 2025. Also, I need food and water shelter at timestamp in 30 minutes. In 30 minutes time. So you're gonna have the polling video. So basically you're gonna have a consensual video. So basically Bob sends an artifact. So using my pen, but not in the camera. So you're gonna have I need food and water now, and now get a vector, like you're gonna have y, you're gonna have b squared minus 4ac. Now b squared plus 4ac is directly proportional. You're gonna work on proportions. So you're gonna have multiple proportions. You're gonna have b squared minus 4ac. So b squared is basically in terms of the system, because it's gonna have minus one. The messenger holds 0. The messenger holds 0. The messenger sends. The message sends. So the message would be no, unconcession, no, no stance, okay, no tap, minus one hold, and yes, minus one sends. When one sends, he creates he has the message on hold until it is sent. So if the message really has time minus one, between minus one, so basically it comes minus one until the time, the download time is 30 minutes time. Sent by Python. So the zip file will be encoded. So the message will be sent, encoded. So the message will be sent in time. So if Bob sends this by SMTP Python, what's the Python file? Python mail.smt or mail.py mail etc. So the message will go to methods and Alice will then send. But if it's now, here and now, those will go straight to Alice. So those will be on timestamp. So if the message is, if there's no timestamp, it should be now. So let's say now, so the codec endpoint will be imported will have to be sent. So the codec will be sent and the decodec will be sent. So the SMTP file and over SMTP. And we'll do something. No, go away. Come back later. So it goes to have this codec system, b squared minus 4 to the power system. This system will be probably bound to kind of the auxiliary system. So it holds a codec memory and it's magnetic. So it's polarized to the Alice. So when Alice receives it, she will see the SIGII artifact NSIGII in an inbox, and then she will have the codec. So basically, so she opens the she's allowed to open the zip file. But she can see the message file, but the codec would reveal what the message is. Because the message is in perfect form. And the second thing I want you to say, guys, message is perfect because the codec is the interface. The codec is the medium. The codec, basically, the SIGII file is the codec. So the SIGII file is loadable, and it's loadable in the inbox. It's like all the package tends to see to come misinterpret information. It's a very communication. But it's magnetic essentially. It loads its codec, and the codec runs based on the current state of Alice. So the current state of Alice. If you can hold something, hold the state But you can have a decay function too. So the case was really one of any type the kind of consensual system. You have the blockade system, good factor of the strength of whatever. Basically, the shape of the curve, the area of the curve, which is just the integration over the derivatives of the message. So the message will be the string, because you're gonna have 3 packets to the but basically 3 packets of sending messages. So the yes, no, maybe. So if one packet doesn't arrive, the second one tries to come. You have three packets. So basically try to polar message. So it sounds kind of intuitive, but I hope this ramble shows you guys that it's possible to have migration. Because the migration is basically things that so quite so basically if Bob was to reply, she has to write so I'm going to try to demonstrate by 2 emails. So I'm going to try to create a fake demo email account and send it as an alias. So I'm going to try to send it to my inbox to check into my inbox. So, but what I'm really what I'm going to have that. So I'm going to create an email, a fake email address, and for testing and send the message. So I'm going to send the single codec and to myself via peer-to-peer channel, maybe one of my emails, but you're gonna have two ways. But if the codec address, there's no update to the codec. What updates? You have to update the codec. So if you have a new codec, you can encode this. Doesn't matter which file you have, image, PNG. You can have an interface. You can define a SIGII interface, and that will be how you use the system. But the SIGII interface is going to be made but the mailer is going to be also the hand about what we all share, and you can never. If you have a rollback to the SIGII file, you're downgrading. If you have an upgrade, you are updating the shared interface you have. But the SIGII files are the linkable executable artifacts that hold the kind of what's expected from an email inbox for what we need and here and now forever. Food was shorter, etc.